Okay, gang, the technology, gotta love it. It knocked me off the video here. So let me try again. We were right here, and we were doing this test value of -6. We can plug it into either of these inequalities. I chose the bottom one. You're trying to see if it's true or false. 7 is not less than 0, so that's false, which means that this domain, this corresponding domain of the number line isn't gonna be what we want. It isn't making this inequality true. So since this one value fails, actually all of them will fail. So once you test one value, it makes all of them false. You could see if you keep testing values in here, they're all false, because the critical numbers will separate the true from the false sections. All right, let's try the next section. So now we let x be 0. Again, well, you know what? I can plug it in the top one because this one is the same no matter what. So again, it doesn't matter which one you plug it in. So if I do it in the top one, if anybody wants to see that, that actually might be easier on this one. So we get 0, 0, and then we get -5 is less than or equal to 0. So that is, that's true, which means that this section right in here all these values, when you plug it into the inequality, will work. They will make the function less than 0. And then if I do the last one, I say x is 2. I plug it into either equation. I'm going to go with the bottom one again now. So I'm going to get 1 times 7. 1 times 7 is 7. So this guy is false. Okay, so this guy was bad. This guy doesn't work, so it means that none of these values will work in here. So we found the answer. Where this parabola is less than or equal to 0 will be for the following x values. So the solution to this, and make sure you write the solution out on the test. The solution to this will be from -5 to 1. I really should say the final at this point because that's the only thing that you have left. Now, just a couple notes here. Because this is closed, I'm doing square brackets, right? That means closed. If this had been open, I would have done parentheses. And I'm going to leave it like this because this is a really nice notation, but you're very welcome, if you don't like what I just did, you're very welcome to write it in inequality. I mean, at the end of the day, I just want to see that you understand it. If you format it like this, that's fine too. Now, let me just show you a picture from your book, because I'm going to actually have you guys, I'm leaning towards assigning this problem, but if I don't, you know, I haven't figured out all your homework yet. Okay, so this is the parabola that I was just working on. This guy right here. Now, so let me just let you see it. But I wanted to know where the parabola was less than 0, and I got that the parabola is less than 0 between -5 and 1. So look at this. Look at this right here. Here's 1, here's -5. Here's 1, here's -5. The parabola is below the x-axis for those values. So that's what you did. You found where that parabola was below or equal to the x-axis. And on these other sides, the reason why we got false is because that's where the graph was above the x-axis, right? It's above the x-axis if we use the x values greater than 1, and it's above the x-axis if we use values that are less than -5. So that's the logic or reasoning. I hope you understand that. It's not necessary to understand that to solve the problem, but that's like what you're doing. You're separating the domain into parts that have a particular characteristic you want. So we found the domain where this parabola was below or equal to the x-axis. Okay, gang, let me see. We're at 4 minutes. Okay, let me leave this one here just because this video got chopped in half. And I'll do some more problems with you. We're going to look at a couple different varieties, but this was like my foundation explanation for you. Okay, catch you in the next video. Bye-bye.